So, some major topics of air or global air concerns, okay? One of them is called temperature inversion. And I've seen this exact diagram come up on the exam, and you have to interpret the diagram. So, basically, when the air above is warmer, the balloons are going to trap. So, if you look here, the normal scenario is hot, cool, cold, it says. As long as you know hot and cooler as you go up, you're fine. Temperature inversions would be this diagram right here, where you've got the cold air below the warm air, so when the balloons travel up, they get pushed back down.
They just stay there.
And it causes, it's one of the reasons why you have like trapped emissions of cars, because everything that the cars are letting out, especially during traffic times, will become stagnant in the atmosphere. And I have a video. Right now, somewhere in your notes, you could write, ozone in the troposphere is and bad. Ozone in the stratosphere?
In the stratosphere is bad.
No, I'm asking you a question. Ozone in the troposphere? Bad. Ozone in the stratosphere? Good. What is ozone in the stratosphere for us? Protects you from, it's like sunblock in our atmosphere, okay? But in the troposphere, it's not good. It is a toxic chemical. So ozone, when it doesn't make it all the way to the stratosphere and it stays in the troposphere, it is a toxic chemical. So it's a pollutant. And obviously, everything I teach you about pollution in the atmosphere or in the troposphere is going to affect plants more than it's going to affect you. Because they're made up of, even though they're multicellular, let's say protists, like phytoplankton, which is the #1 producer, that's a single-celled photosynthetic organism. So they don't have tissues to help fight these kind of toxic chemicals. It damages tires, so apart from health issues, this is something I'm going to ask you to do tomorrow. It's not just name what are the effects of on you, it's what are the effects on other things. And there's a picture of ozone being referenced as bad in the troposphere and good in the stratosphere. So here's a diagram of the atmosphere, and it's showing you bad ozone is found in the troposphere, good ozone is found in the stratosphere, that's your protective ozone layer, and smog is a result of trapped pollutants. Major global air pollution problems we're going to talk about, what are they? Smog. Acid rain. Ozone depletion. Global warming or climate change or whatever you want to call it, but at the end of the day, there's warming of Earth due to climate change, so I guess we should add that. Climate change / global warming. It's air pollution that hangs usually over an urban area and it reduces visibility. Now, you have to be able to associate each one of these major global problems with what contributes to it. So, at the end of the day, smog is a mixing of primary and secondary pollutants with the reaction of the sun. So, because we know transportation is our key contributor to most problems, cars produce the following: nitrogen, sulfur, VOCs, and particulate matters. So they produce everything that I taught you as a primary pollutant. I took off carbon dioxide and carbon monoxide. So if you want to write yourself a note, smog includes all primary pollutants except carbon dioxide and carbon monoxide, feel free, because that'll help. Now, they react. See, here's my contributors right here. Emissions, you see them? This is coming from a home. Let's say that's a car. They somehow react and form ozone or mix with ozone and mix with particulate matter and form smog. So you're gonna have some kind of reaction between any of these primary pollutants, along with, so the sun triggers this, and you're gonna get smog. Okay, so you can have ozone and particulate matter and get smog. You can have all these primary pollutants reacting and mixing, forming secondary pollutants and get smog.
So,
You do not have to know the balanced reaction for smog. So if there's a question about smog on the AP exam, the answer is going to be Los Angeles, okay? Because they had a serious case of smog to the point where, here's just something I found. It costs about $520 million a year to deal with smog, and this is school absences is what they're referencing. So there's 36% of students were absent, like during a time where the smog levels were high or whatever, or got sick because of it. That's what they're trying to reference here. All right, acid deposition, which you've constantly referenced as acid rain. That's what you know, okay? Well, the term in higher terms is deposition because it's not always just wet, it could be dry deposits too. So that's why they consider it acid deposition. Now this reaction, you have to know. So what's involved? Because we've kind of covered this before.
Sulfur.
Sulfur and,
Carbon dioxide.
nope,
and hydrogen.
nitrogen. Sulfur and nitrogen react with what?
Water.
Water and form what?
Wait, what does it say in the newspaper?
That red line I just added.
Hydrogen reacts with
Sulfur and water react to form whenever you add an H in front of a chemical formula. So I have nitrates
Sulfide.
or sulfates, then I have what?
hydrates.
Sulfide.
It's like acid.
Yes, what kind of acid?
Well, I don't know if it's like hydro.
Sulfate.
Sulfuric acid and nitric acid.
Yeah.
So, and what I meant here was wet deposits will come down as rain, snow, or fog, and dry would be just particles of acid. So you're gonna have like dry particulate matter that's acidic. And then I added to the page some referencing of acid rain. I promise you, this is an AP test question right here. What is considered acid rain? And if you're gonna interpret this graph, what is considered acid rain?
3 and a 4. And pH.
If I tell you, look at this graph and tell me what is acid rain range, what is it?
3 and 4.
No.
Anything about 7?
You're getting on the right track. No. I'll zoom.
Anything under 7?
4.
4 and above.
Not 4.
5.
2.
This
1 through 4.
Less than 5.6.
2.
Less. Well, 5.6 is normal rain, and that's about here. So what's this?
So 4.
5.7 and
4.5 or below.
above.
Okay.
Oh.